Can you all see my screen? Can you see my screen?
Yes, sir.
Okay. So I'll do a little bit of recap from day 7. So we discuss about the dimension. So we define what the dimension is, and then we discuss the two types of dimension, the size and the location dimensions. Then we discuss dimension in symbols. So most commonly the diameter and the radius symbols. And then we discuss what are the elements of a dimension and what to consider, how to place them. So we discuss about the preferred practices and what are the incorrect things. And then we discuss about type of dimensions. The first one is chain dimension, and then we discuss baseline dimension. Lastly, the direct dimensioning. So we compare all three and pros and cons of all three types of dimensions. So then we discuss about how to place a dimension on a holes. Then we discuss about how to place a dimension on a countable and countersink. And we discuss about polar coordinates, where to use them. So then we discuss how to place all three views or multiple views on your sheet. So we discuss the steps we have to follow, the general steps. And also I have given you some text to read, how to calculate the space. So those things we have discussed last day. So any questions about dimensioning? No questions. Okay. So today we are going to learn about tolerance. So this is a very important topic. So a tolerance is the total permissible variation in a size or location dimension. For example, if you say, let's say you want to make a rectangular, let's say this kind of box, then in your design you can define, let's say this is 50 millimeter. So when you produce a drawing and then send it to a machine shop to do the machining, so they won't be able to produce this dimension as it is. Like there can be some variations. So these variations comes from practical reasons, because in their machines they have some variations, machining variations. So you might get 50.1, let's say you are going to manufacture 10 of these boxes, right? So you anticipated this to be 50, but you won't get the exact 50 when you receive all of them. If you measure, you can see that some could be 50.1, some could be 49.9. So likewise, so this is due to the variation in the machining process. So you won't be able to get the exact value. In certain cases, in randomly, you might get exact value. So, but you cannot expect that to happen every time. So, therefore, when you define your drawings, you have to give some tolerance. So, this tolerance value, you cannot put any arbitrary value. You have to think about your design, as well as you have to discuss with the machining shop what are the tolerance values they can achieve. Because let's say if you define 50.001 tolerance, right? So your main value is 50 and your tolerance is 0.001, right? So your machine shop, if their machines cannot handle this kind of tolerance, then there is no point of placing this kind of tolerances. So you should think about all the practical reasons. And also, when you do the design, sometimes you might remember that when you put very fine tolerance value, it will increase your cost of production as well. So you have to be very careful with the tolerance. So that's why at the beginning I mentioned tolerance is very important. And also, if you, let's say if you put a wrong tolerance, for example, let me clear this screen first. Okay, so let's say you have a shaft like this, right? And then you have some, let's say another part here, there is a hole, right? So let's say this dimension is 50 and you want this to be, let's say 50.5. So let's say your machine shop tolerance is 0.5. Then you might get this as 50.5 here, and here you maybe get 50 because you have tolerance. So then this will not, this shaft cannot insert here. So any questions about this tolerancing up to now? No questions, right? So dimensions are placed on a drawing to make sure that parts fit together in an assembly and that all parts function as intended intended in that assembly. So in here, this value is we call dimension, and here this one is the tolerance value. So when you put tolerance, you have to be careful here. If you place 15 plus or minus 0.2, it is wrong. It should be 15.0. So you have to put exact decimal points same as your tolerance value. So there are several methods you can define tolerance.
Excuse me, sir.
Yes.
Sir, මට සර් කරන කිසි දෙයක් මේ ස්ක්‍රීන් එකේ පෙන්වන්නේ නැහැ. මේ තරුදු චන්දම කියලා වැටලා තියෙනවා. උඩින් TC කියලා වැටලා තියෙනවා. එච්චරයි පෙන්වන්නේ, වෙන කිසි දෙයක් පෙන්වන්නේ නැහැ මට.
අනිත් අයට පේනවද? එක්කෙනෙක්ට විතරද පේන්නේ?
අපිට නම් පේනවා ක්ලියර්.
සමහරට වයින්නවා මෙහාට හයියෙන් මේකින්ද මේ නෙට්වර්ක් ඉෂුව එකක්ද දන්නෙත් නැහැ. සමහරට පෙන්වන්නේ නැහැ කිසිම දෙයක්. සර් වොයිස් එක ඇහෙනවා. ඒ වොයිස් වල ක්ලියර් ඒ ප්‍රශ්නයක් නැහැ. බට් ස්ක්‍රීන් එක පෙන්වන්නේ නැහැ.
අනිත් අයට පේනවා, ඔයාලට පේන්නේ නැහැ කියන්නේ එහෙනම් නෙට්වර්ක් ඉෂුව එකක් වෙන්න ඕනේ. එහෙම නැත්නම් ඔයා Teams එකෙන් disconnect වෙලා ආපහු connect වෙලා බලන්න.
ඕකේ මම රීජන් එක නම් අතර ඇක්සෙප්ට් කරනවද?
ආපහු connect වුණාද? කවුරු හරි කෙනෙක් පොඩ්ඩක් යාට කෝල් කරලා බලන්න කනෙක්ට් වෙන්න පුළුවන්ද කියලා. connection issue එකක් තියෙනවද? දැන් screen එක පේනවද?
now okay.
Right. Right. So there are several types of tolerance methods. So first one is plus minus dimensioning. So a bilateral tolerance is allowed to vary in two directions from the specified dimension. So if you can see here, so the main dimension is 6.5 and your tolerance could be above 0.1 or below 0.3. So this is we call unequal bilateral tolerance, because your tolerance value from your specified dimension is unequal. But if you look at here, it is equal bilateral tolerance. Your specified dimension is 6.5 and your tolerance could be 0.2 above or below from this value. So it could be 6.7 or 6.3. So bilateral tolerancing is the most common tolerancing method. So manufacturers typically prefer equal bilateral tolerancing because they attempt to manufacture features as close to the specified dimension as possible. So if you define like this, equal bilateral tolerance, your manufacturer will anyway try to achieve this value, right? So in their machines with their variations, so this tolerancing method, so this is your like a mean value. So it could be your final dimension could be plus or minus from this value, but your dimension is so critical, so you can use unequal method. So any questions about this plus minus dimension? Okay. So other one is unilateral tolerance. So it varies only in one direction from the specified dimension. So you can see one tolerance value is 0 and other one is -2. So you can get the parts like the range is one is 22 and other one is 21.8. In here, one side is 20, other side is 19.5. So next one is limit dimension. The extreme values of the tolerance are given in the dimension itself. The upper limit is the largest feature can be within the given tolerance of the dimension, and the lower limit is the smallest feature can be within the given tolerance of the dimension. So you can see, you can define like this as well, or this, but the most common method is this plus minus dimension. So that will save some space in your drawing. Any questions about this? So next topic is specified and unspecified tolerances. So we can define the tolerance in the title block. So it will be a general tolerance. So you don't have to specify that tolerance each and every dimension in the drawing. So you look at this dimension here. So it is stated that 12.5. But in your drawing cage, the title block, tolerance, under the tolerance, it says ISO 2768. So when you produce this kind of method, your manufacturer will know that if he follows ISO standards, he can get the tolerance chart and he can get the tolerance value. Let's say your dimension has a specific tolerance. So then you have to specify that in the dimension itself if it is deviating from the standard tolerance value, like this. So any questions on this? So next thing is we are going to discuss about the material conditions. So there are two kinds of material conditions. First one is a maximum material condition and the next one least material conditions. So let's see what is maximum material condition, or we call it MMC. So it is the condition of a part or feature when it contains most amount of material within the stated limits. So in this word MMC, the keyword is most material. The MMC of an external feature is the upper limit. So let's see this figure right here. So you have defined the tolerance as 0.15, and so your actual size could vary from 15.15 to 14.85. So if you have this dimension, the first one, 15.15 value, then you have the maximum material. So this is an external feature because in this cylinder, this is your diameter. But if you consider a hole, if you define your tolerance like this, your lowest value is the MMC, because so if you have a circle like this, then you have the most material. Any questions about this MMC?
Is MMC having the concern on the area of the material or material? The density of the material?
I didn't get that question.
The MMC in the sense maximum material condition. No? So
Yeah,
if the
yeah.
drawing is having density of the material, that means how much material contained in that drawing Is that the one we'll have to consider, or the area of the side view?
That's the, if you consider, let's say you want mentioning in only this view, no? So
Yeah.
you have some side view as well, right? So let's say you define this as a constant, right? And then even though you consider this as an area, then you can convert it into density as well, right? So by looking at that view only, we can define MMC.
Okay, got it.
Because MMC is directly related to the dimension. So I hope I answered to your question. The next one is the opposite of that, MMC, least material conditions. So it has the least amount of material possible in the size of a feature. So LMC of an external feature is lower limit. So in the external feature, this is LMC. Internal feature, this is LMC, this value. So any questions about MMC, LMC? No questions, right? So the next topic we are going to discuss is the fit. In engineering terms, the fit is the clearance between two mating parts. The size of this clearance determines whether the parts can move or rotate independently from each other, or at the other end are temporarily or permanently joined together. So you have to define a correct type of fit. There are three types of fits defined. First one is clearance fit. So the clearance fit is the hole is larger than the shaft, enabling two parts to slide or rotate when it is assembled. So if you see this figure here, so this is your shaft and this is your hole here. So maximum or design size of the shaft, this one. And your tolerance is shaded in red color, and this is your minimum diameter. So your shaft can vary from here to here. And in your hole, inside it is vary from here to here. So in the clearance fit, if you consider the maximum value and the minimum value of your hole, there should be a clearance. So that's your minimum clearance. If the shaft has this value and your hole is this value, then it is your maximum clearance. If you consider this example one here, on the right side, your shaft can vary from 18.95 to 18.90, and your hole 19.10 to 19.05. So if your maximum size is in the shaft 18.95 and the minimum of hole 19.05, so you can easily insert this because there is a clearance definitely at any given dimension. There is a clearance, so that's the first clearance type. Any questions about this clearance fit?
ඒක චුට්ටක් පුළුවන්ද මේ ආයෙ එක්ස්ප්ලেইন කරන්න හේතුව මම ස්ටක් වෙනවා මැෂින් එක අර මේ රෙඩ් කලර් ඩ්‍රෝවින් එක කරගෙන යද්දි ස්ටක් වෙලා පේන්නේ නැතුව යනවා.
Right.
ස්ක්‍රීන් එක පේන්නේ නැතුව නෙමෙයි අර මේ පෙන්සල් ඉදි පේන්නේ නැතුව. චුට්ටක්
Right. මේකේ shaft එක vary වෙන්න පුළුවන්. අපි හිතමු අපේ max අපි define කරන size එක මේක කියලා අපේ design එකේ. එතකොට අපේ tolerance එක අපි හිතමු එක පැත්තක් 0 අනිත් පැත්ත minus කියලා. එතකොට අපේ minimum diameter එක වෙන්න පුළුවන් මෙන්න මේ value. එතකොට අපේ shaft එකේ අපි 10ක් හැදුවොත් මෙන්න මේ ends දෙක ඇතුලේ තමයි අපේ shaft එකේ එන්නේ diameters. එක්ක minimum වෙන්න පුළුවන්, එක්ක maximum වෙන්න පුළුවන්, එක්ක ඒ අතර මැදගියක් වෙන්න පුළුවන්. hole එකේ අපේ minimum එක අපි හිතමු අපි design කරපු size එක මේක කියලා මෙතන. එතකොට hole එකේ tolerance අපි හිතමු plus පැත්තට තියෙන්නේ කියලා. එතකොට අපේ maximum hole diameter එක ඉන්නේ මේ value එක. එතකොට hole එක වෙනස් වෙන්න පුළුවන් මෙන්න මේ අතරේ. ඒ මොන condition එකේ මොන tolerance value එක ආවත් හැමතිස්සෙම අපිට clearance එකක් තියෙනවා. minimum clearance එක වෙන්නේ hole එකේ අඩුම diameter එකයි shaft එකේ මෙතන වැඩිම diameter. එතකොට තමයි minimum clearance. අනිත් වෙලාවට ඒ කියන්නේ අපිට shaft එකේ අඩුම එකයි hole එකේ මෙතන වැඩිම එක ගත්තොත් එතකොට clearance එක වැඩි. ඒක තමයි maximum clearance එක වෙන්නේ. දැන් පැහැදිලිද?
ඔව් clear වුණා.
Right. So any other questions about clearance fit?
හැබැයි මේ maximum clearance fit එක යද්දි සමහරලාට ඔය වගේ එකක play එකක් එන්න පුළුවන් හැකියාවකුත් තියෙනවානේ.
ඔව්. ඒක තමයි clearance fit කියලා කියන්නේ. තව fits දෙකක් තියෙනවා. ඒකෙදි විස්තර කරනවා කොහොමද fit එක clearance එක අඩුවෙන් යන්නේ කියලා. play එකක් නැති වෙයි.
හරි.
සමහර parts වලට අපිට clearance fit එකක් ඕන වෙන වෙලාවල් තියෙන්න පුළුවන්. The next one is transition fit. Hole is fractionally smaller than the shaft and mild force is required to assemble or disassemble. Someone has turned on his mic. Any questions? So in the interference fit, let's say your design size is like this shaft, and your whole design size is like this. So this is like a very exaggerated view. So in the interference fit, at any given dimension size, there is no clearance. It is an interference. So let's say you get this shaft size, the maximum value, and the maximum size of hole, still you can't insert. So when you want to insert this shaft to this hole, in practically, what we'll do is there are two ways. Let's say you are inserting two metal parts together, then either you have to heat this part, apply some heat, then this hole will expand, and then you can insert, and then you let it cool, right? Then it will fit, and you cannot remove it in the room condition. It is tightly fit in the interference fit. Or else you can pull this part, this shaft, and then you can insert into this hole. Then you allow some time to get it into the room temperature, and same effect will happen. You cannot remove it this from the shaft. So the next one is the transition fit. So it is in between interference fit and the clearance fit. So in the transition, the hole is fractionally smaller than the shaft, and mild force is required to assemble. So in here, the design size is like this. And let's say your maximum hole size is like this, then you have small clearance. But in the shaft, the minimum diameter and the maximum size of the hole, then you have some interference. So in the transition fit, you can have the clearance as well as the interference. Any questions about these types of fits? Right, no questions. So there are two types of bases when selecting the tolerance. So first one is hole basis and the second one is shaft basis. So you can fix the hole and you can vary the shaft size to get the different fits. So the clearance transition and interference. And the second one is the hole basis. Sorry, the hole basis is you fix the hole size, and in the shaft basis you fix the shaft and vary the hole. So there are certain examples for this. Let's say you have a motor and you are going to design some parts that fits into the shaft of the motor. In that case, you have to go for the shaft based system, okay? Because you cannot change the shaft of the motor. So you have to vary your design part so that it has the required fit. So it is shaft based. But let's say you have a bearing. So bearing, there is inner circle and outer circle, and in between you have steel balls. So you are not going to manufacture this bearing. You are going to purchase from the shop. So in that case, you have to change your shaft to match this bearing in order to get your type of fit, the clearance or transition or interference. Any questions about this shaft basis and hole basis? Okay, no questions. So now we are going to explore what are the tolerance values for each fit type in the hole basis. So in this figure, this is your hole, right? So imagine this is your center line, right? So it is only one part, right? So there is a mirrored part in the bottom, but in the figure it's only one side, right? This is your hole. So in the hole basis, you are not going to change the hole. So it's like a zero value here, and you are varied from this baseline to here, from this side. So there are several tolerance values. So these are standard ones like H11, H9, H8, H7, like this. In here, this side, see, it is the shaft, right? In the clearance fit, in the definition we discussed, there is always clearance, right? So this area, it is clearance. But in the H9D9 configuration, the clearance is reduced. So F7, right? And then when you go to transition in the hole basis, it is either clearance or interference. But in the interference fit, your hole is vary from here to here, but your shaft is here. So you cannot insert it directly. Either you have to cool or heat the respective part. Any questions on this?
Excuse me, sir. Can you explain it again?
Yeah, okay. So so your hole varies from here to here. Okay? I'm talking about this H11 C11 configuration. So in your part, this is your say you have center line. So this is your hole diameter variation, right? And your shaft is like this, right? And other part is like here. This is center line. So your shaft varies in this region and your hole varies in this region. So at any given value, you can easily insert this shaft into this hole here, right? But in the D9, so the clearance is reduced. Likewise, it is getting reduced. When you move from clearance fit to interference fit, your shaft is like this. Shaft vary from here to here. But your hole varies in this region. Right? So you cannot insert this shaft to this hole at any given dimension.
Okay, sir.
Right? So in the hole basis system, you have to let's say your hole diameter is 50, then you can define this as H9. You don't have to type plus or minus value here, right? You just have to type diameter 50 and capital H, right, in the hole basis. And also in the shaft, in the drawing, you have to type diameter 50 D9. It is simple, right? So when you see this, the capital value here, it is, you can see that it is hole basis. And here it is simple. So you know that this is hole basis. In the shaft, you have to use simple letter.
Yeah.
So by giving this numbering system, the manufacturer has a table so that he can identify what is the tolerance range. Right. So any questions?
ඒක නම් හෝල් බේසිස් කියන එකම ක්වෙස්චන් එකක් වගේ.
Right. Shaft basis එකත් බලමු. ඊට පස්සේ දෙකම එකට compare කරමු. Right? Shaft basis එකේ ඒකේ වෙන්නේ අනිත් පැත්ත. මේක ටිකක් tolerancing part එක ටිකක් tricky. මේක පොඩ්ඩක් එකපාර කිව්වට සමහරක් වෙලාවට තේරෙන්නේ නැහැ. මේක පොඩ්ඩක් සර්ච් කරන්න. මේක ගොඩක් එන්නේ ඔයගොල්ලන්ට ඩිසයින් පාර්ට් එකත් එක්ක ඩ්‍රොයින්ග්ස් කරද්දී. මොකද මේ සමහර වෙලාවට ඔයගොල්ලෝ ඉන්ඩස්ට්‍රි වැඩ කරනකොට ඔයගොල්ලන්ට ඩ්‍රොයින් එකක් එන්න පුළුවන් වෙන කවුරු හරි ඩිසයින් කරපු එක. එතකොට එයා C11 H11 කියලා දාලා තිබ්බොත් ඔයගොල්ලෝ දැන් ඉගෙනගෙන තිබ්බේ නැත්නම් මේක මොකක්ද කියලා ඔයගොල්ලෝ වැරදි පාර්ට් එක තමයි ප්‍රොඩියුස් කරන්නේ. හරි. In the shaft basis system, this is your shaft. This is the base size and this is your reference, right? You are not going to change the shaft size, right? So think about this is a shaft of a motor, right? So when you purchase a motor, you are not going to machine and reduce the size of the shaft in the motor. So you are going to change the hole in your design part. So in there, hole is like this. It is vary in this region. Shaft, it is vary in this region. So your minimum hole is like this in the clearance fit, let's say, and then your shaft maximum size of the shaft is like this. Then you can insert this shaft to this hole. So likewise, in the when you go from clearance fit to the interference fit, your clearance is getting reduced. Likewise, and then in the shaft, in the interference fit, all is vary in this region, and your shaft is here. It is vary in this small region, so you cannot insert it. We have to use heating or cooling method. So I'll move forward, and when we do some examples, you can get an idea how this is working. So there is a ISO standard about this shaft basis and hole basis method. So in the hole basis, you are defined like this. H11 H capital, C is C11, C is simple, that's used for shaft. But in the same way, shaft basis, you have to use capital value for shaft here. So although there are 3 types of fits, the clearance fit, transition fit, and the interference fit. So within that clearance fit, there are few other clearance as well. So it is there are several type of names. So for example, loose running fit, free running, close running, sliding fit. So your clearance is getting reduced from this direction. In the transition fit also, you have these kind of names defined. So you don't have to every time memorize these things, but when you see this kind of notation in your engineering drawings, then you can always refer textbook and get the idea. Okay, so this is an example of standard tolerance table. So I am going to tell you how to define a tolerance from this chart. So here, so this chart is for whole basis. So this you can see that your whole is reference. This way, no? This reference, and your shaft is varying. So that's whole basis. So in here, in this first column, it says basic size in millimeters. So I am going to design a shaft, and its diameter is, let's say, 7, right? Then you have to select this one. The range is 6 to 10, right? So it's 7 is here, right? So first you have to select what is the diameter of the shaft I am going to design, right? Next, I need to define the type of fit. So there are 3 types of fits defined here: clearance fit, transition fit, and interference fit. Right. So in the diameter 7, let's say for this, let's say I go back to this chart. Let's say this one, H7 G6, right? I need a sliding fit. So the sliding fit is not intended to run freely, but move and turn freely and locate accurately. So this is the fit I need. So I select H7 G6. Then I go back to this chart, and my diameter is 7. Then I go here, right? This pair, H7 G6, right? So I go this way horizontally and vertically this way, H7. So this is my tolerance value, right? So it says 15, 0 here in the H7, G6, 5, 14, right? So it's a bit smaller, but I will read out for you, right? So this is 15, 0 and 5, 40. So H7, 15, 0, G6, 5, 14, right? So in the description it says upper and lower deviation for clearance. So upper and lower deviations for tolerance class value micrometers, right? So micrometers 15 is 0.015, right? And this is 0. In the G6, the micrometer value is 0.005. Other value is 0.014. Right? So in your shaft, although it is design size is 7, right? H7, your hole is very in this range, 7.015 or either 0. because your lower limit is fixed, right? And in your shaft, it is vary from 7.005 to 7.014. So same way, if you want to design another value, let's say 34, you have to pick this range, right? But let's say it is 30, then there is two values, right? 18 to 30 and 30 to 40. So we have to carefully look at here. So it says this value, this figure is above, and this is up to and include, right? So this is if your shaft size is 18.1, then you have to select this one, right? Not here. 18 is included here. 30, you have to select this, not this one. If it is 30.5, then you have to select this range. So you have to select 30 here, and then you have to select which type of tolerance, which type of fits I'm going to have. So likewise, you can select H7K6, and then you can get this value 25.0, 18.2. Any questions on this? Any questions? No questions. So this is this chart is for whole basis, and there are charts for shaft basis as well. So the whole basis is most common. Shaft basis is less common because it is the applications are little bit low. Okay, so next we can see in this drawing it says 510 the diameter and H7. So this is whole basis, right? And here 14 and this is also, this is a shaft basis. So likewise, you don't have to type the tolerance value. You can just use a standard tolerance like this. So this is little bit tricky part, and I suggest you to read more. And there are many YouTube videos as well about explaining this shaft basis methods and how to select the tolerance values. So I suggest you to watch them and read more. So do you have a machine design module in future, the next semester or after? So you don't know whether you have or not, right? Okay, so this type of tolerancing is important when you design machines. So in the engineering, we have to select correct type of fits. So this is about the tolerancing, and next day I am going to discuss about geometric dimensioning and tolerancing, or we call it GD and T, right? This is the short form, right? So I'm not going to explain this today because this is a whole new type of dimensioning and tolerancing method. So this is about for example, how to define the flatness, cylindricity, likewise. So those things I will explain you in the next day. And then I want to teach you some SolidWorks as well. So any questions about today's lesson, the tolerancing? Okay. So last time or before that, we discussed how to draw a few basic shapes in SolidWorks, right? So I'll start with new file. So file, and then you click new. So if you open in the first time, you might get this window, right? And there is a button called advanced, right? Or else if you in the advanced menu, you can click this one, novice, right? So let's say I can go to part, click this one, and click OK. Right. When you open a new part, from the left hand side, you can see front, top, and right planes and the origin. So you can click front plane and press shift and click the right plane. Then you can select all three planes and right click here. And then there is a logo like this eye. So it's a show button. By default, the planes are hide, and then you have to enable them. So click show. Then you can see all three planes. You can rotate using the middle mouse button, the scroll wheel. And if you right click somewhere the empty space, you can rotate like this, or right click pan. Then you can left click the mouse button and you can pan it like this. Anytime you want to exit, you press escape. Okay, so I'm going to show you how to draw a circle, cylinder, and make a small drawing out of it. So I select front plane, and then if you click it at once, there is a small pop-up window, and the second option is sketch. Or else last time I told you can go to sketch option here and select sketch. Then it will give you a message, select a plane on which to create a sketch for entity. Then you can select display, right? So both ways it's okay, but it is easier to click this this plane and click sketch. So any questions? Okay. So when you in the sketch environment, you can see here there's a sketch button and the cancel button. If you see like this, you are in the sketch mode, right? So this in the sketch mode, the sketch tab is activated. If you are in another tab, then you can click the sketch tab, right? Then in the same way as AutoCAD, you have the sketch tools, right? So since I am going to draw a cylinder, first I will need to draw a circle. So I click circle, and there are circle types. First one is you can see first we have to define the center, and the second point is like this. First one is center, and the second point is here in the as a radius, right? Other type is, you click here, this is 3-point circle, right? So click 1, 2, and 3. You are not defining the center, but you are defining 3 points in the circle. But if you remember in the AutoCAD, there are many types of circles like tangent, likewise. But here it's not available because we can achieve the same thing with some commands. So I will describe that later. So first I will create a circle by defining the center point and click somewhere here, right? But in the AutoCAD, you have to draw it exactly the dimension you want. Let's say 50 millimeter, then diameter, then you have to define at first. But in SolidWorks, you don't have to, because you can change it anytime. Even after creating the cylinder, you can change the diameter later, right? So now we have placed the center in the middle, right? And then I go to Smart Dimension button and click here, right? When I move my cursor towards the circle, the diameter, there's a circle logo in the mouse, right? You can see, right? And also circle, the blue color symbol becomes orange. So now you can click and you can define the diameter, right? can place somewhere here, and it will ask you to enter the exact value, right? So now it is 86 something, so let's say 80. Let's say I want 50, then I can type 50 like this. Anytime I can double click the dimension and enter new value. 60, enter. Then I will have to see whether I put all the dimensions or not, because last time we discussed the two types of dimension, the size and the location. So in the circle, I have defined the size, the diameter, but I didn't define any location here as a dimension. If you can see, let's hide this plane for a moment. So you can see there's a green dot here, green logo. So that's called relationships. So in this, the relationship is the center of the circle is coincide with the origin point of the SolidWorks. So the location is we define. So if we enable the plane, so you can see, right? If I place somewhere here circle, I put the same dimension 60, right? You cannot see this green relationship button, so I can move it here and there, right? But here you can't move it, it is locked. And also in the circle, there is a black color. The sketch become black color, but here it is blue because it is not fully defined, right? So if you look at the bottom of the screen, it says underdefined. It's not fully defined because one of my sketch entity is not fully defined, so that the whole sketch is underdefined. So we have missed some dimensions. For example, if I put dimension from this surface, this plane to here, let's say this value, and then still it is underdefined because we place this dimension 20.28.75, so it is locked, but I cannot move it this way, but I can move horizontally. Vertically I locked, right? Because I have defined a dimension. When I insert another dimension here, now you can see the sketch become fully defined, right? Because both my circles are fully defined. The size dimensions and the location dimensions with reference to existing planes, right? So any questions about this? So I delete this one. Any questions before I move forward? Okay, no. Right. So I have drawn this circle in the front plane. If you rotate little bit, you can see all three planes, but my circle is in the front plane, right? Let's see. Right. If you want to go back to perpendicular view, you have to click here, this view orientation, and there is a normal to button here, right? Once you click this, your sketch become perpendicular to you. right? So next step, I want to make this circle to a cylinder, right? So in that case, first I will have to exit from the sketch mode because I am going to use a 3D command. So here there are two options. Either you can cancel this. If I cancel this, the whole sketch will be deleted. So I will have to use this one. Right? Now my circle is there, right? And it is defined here as well. This area we call feature tree. So whatever the features we add to this part in SolidWorks, it will be listed here. So my sketch is here. So if you want to change, you click this one, and you can, in the pop-up menu, you can edit sketch. Right? You can change it again back to, let's say, 70. Likewise, then you again click this button. Right? So I think up to now it's clear, right? Any questions before moving? Right. Next, I'm going to use a 3D command. So in the tab section, I need to go to features here. And there are a couple of 3D commands available. So I need a 3D command called extrude. So if I click this, right, then it will ask to create a sketch and then extrude, or I can select existing sketch to use for this feature, right? Two options. So when you use SolidWorks, you have to read these messages. So I'm going to use existing sketch. So I can select this sketch. So I move here and select this circle, right? So when I click this one, so it will give you a preview, right? So by clicking this arrow and drag it, you can define the height of the cylinder, right? Or else you can type it here from the left side window. The option is boss extrude. So the boss extrude is the base like this, and you extrude it. So there are a couple of options. First one is blind. So blind option, you can type the value, the height, let's say 60. Once you type it, it will update. Let's say 80, you can update it, right? So let's say 80. And the next one, these options you need when you design complex objects. So I'm going to show you the first one, the blind option, where you define your height of the cylinder, and it is starting from the front plane and one direction, 80, right? If you select this option and click the last one, mid plane, you can see that your 80 dimension is divided, right? So your total height is 80, but it is not starting from the front. It is both directions. And also another option is, if you, let's say you want this cylinder extruded from the all the way from front to the minus side, then you go to blind. Now it is in, let's say, in the positive side. There is a button here, reverse direction. So you click this one, it will become other way, right? Right. So normally when we do a design, we select all the planes to be symmetrical normally. So I use mid plane. And then click OK. So now your circle becomes a cylinder. Any questions on this? So once you created the cylinder, a new set of 3D commands will appear, because these commands did not activated because we don't have any 3D objects. So these are dependent tools. So these ones are the ones we use to create the 3D objects, and other ones totally depend on these ones, right? So next I'm going to save this one. Let's say I am taking the desktop part 1. Okay, save. So your extension of the part file is SLDPRT. Next, I need to create a drawing. So in order to create a drawing file, I go to File, New, here or here, right? So click New and then click Drawing and click OK. So then it will ask you to select the sheet size, right? So I will select, for example, A3. So A3 here. Click OK. Right. So now you have the drawing cage. So the drawing cage will vary from standard to standard, but you can define your own drawing sheet format. Right? So now you have to go to View Layout here, and then you can click this one, Standard Tree Views. Then it will ask you to select the part to assembly. So which part I'm going to so I'm getting a message. You haven't installed SolidWorks. Okay, that I know. So I just want to show you some basics so that you can install and do a basic drawing. So basic cylinder and a drawing of that. So click the standard 3 views, and then it says these are the already open parts, the part 1, or else you can click browse and you can pick already designed part file, right? So I'm selecting this one part and click this tick button. Right? There you see all three views are automatically generated. Right? So this is the power of SolidWorks. But for this object, you don't need all three views. You need only two, because this view and this view are the same. So I click this one and delete. So this is how you create a view. So you can move here and there, right? So your alignment is there, right? Not like in the AutoCAD. So once you move this one, your link view comes with that, right? So now I want to add a dimension. So there are two ways. Either I can put a manual dimension here, or else I can use the dimension which I used to create this cylinder, right? So there are few advantages if I use the original dimensions, right? So there are two options here. First one is the smart dimension, where I click this and there is a dimension but logo appears with the mouse cursor. So I click here and I can place the dimension, right? And same way I can put the length here, the height, right? Okay, so if I double click this, I cannot edit the value because I manually put the dimension here, right? That's one way, right? So I delete this one and delete this one, and I go to model items, and here there are many options, but we select options entire model because I want to add the dimension to the entire model. And then I click this one, the dimensions, and then I click OK here. Now the dimensions are added automatically, right? These dimensions are from the part file. Right? So if you double click, there is a modify button appear, the logo, then you can edit the value. Let's say 85. You can either regenerate, you can see it's 85 updated. So let's say 65, regenerate, and then click OK. Now it's 65, right? If you go to window and go to this part file, if you double click here, you can see this part is updated 65 because I have edited that from the drawing, and also I used the dimensions from this the original dimensions I inserted into the drawing. That's why I was able to edit in the drawing. So this is how you create a cylinder and basic views in the SolidWorks drawing. So either you can save it, right? You can click save. So it will ask you to save the original part file and the drawing file. So part file is SLD PRT, drawing file is SLD DRW. So both the drawing file is linked to the part file. That's why you were able to see the update from 80 to 65. Update you can see from the drawing as well as in the part file. So now click save all, and then I can save drawing file. After that, you can save it to PDF by clicking save as, and there are a couple of options. You can select PDF and then you can save it. So it will take a few seconds and it will automatically open for you, right? The drawing. So this is very simple, I guess, when you able to install and try it out. So I just want to show this to you so that you can install and try this. So not like in the AutoCAD, there are many tools that help you to create the drawings, and since some of the tools are automated, you just have to be careful to use those, because if you remember that when I create the drawings, it will automatically create 3 views for you, but I don't need 3, because in the theories we have learned that we have to use minimum number of views. We don't want to create duplicate views. So SolidWorks does not have a brain, so you are the brain, so you have to think and you have to use it carefully. So any questions?
සේව් කරලා ගොඩායි කියලා දෙන්නකො.
සේව් කරන හැටි.
ඔව්.
මොකක් සේව් කරන හැටිද ඕනේ?
මේ අර page එකට සේව් කරන්න ඉවේ.
ඒ කියන්නේ
layout එක අරගෙන. ඔව් PDF එක මුලින් නම් අර සේව් කරපු විදිහ පොඩ්ඩක්.
right. මෙතන ෆයිල් ගිහිල්ලා normally ෆයිල් එකක් සේව් කරන විදියට තමයි click save. දැන් මේක මම සේව් කරලා තියෙන නිසා එතනමයි සේව් වෙන්නේ. නැත්තම් දැන් මේකේ save as කරොත් ආයෙ මම වෙන තැනක සේව් කරන්න. හැබැයි ඔයාගේ හැමතිස්සෙම drawing file එකයි part file එකයි link වෙලා තියෙන්නේ. එතකොට වෙන්නේ ඔයා part file එක තැනක save කරලා drawing file එක තවත් කොහේ හරි save කරලා ඔයා කාට හරි drawing file එක විතරක් copy කරලා දුන්නොත් open කරලා බලන්න කියලා එයාට ඒක open කරන්න බෑ. මොකද ඔයා part file එක යට දීලා නැහැ. මොකද ඒ file දෙක link වෙලා තියෙනවා. ඒකට drawing file එක open කරාම අහනවා කො part file එක. part file එකව දීලා නැහැ වෙන කාට. ඒක AutoCAD වල එහෙම දෙයක් නැහැ. AutoCAD වල කොහොමත් එක file එකනේ තියෙන්නේ. ඒකට දුන්නාම ෆයිල් එක ඕපන් කරන්න පුළුවන්. මේකේ එහෙම බෑ. මේකේ ෆයිල් දෙකම දෙන්න ඕන. අනිත් එක මේ දැන් මම A කියලා ෆෝල්ඩර් එකක් ඇතුලේ part ෆයිල් එක සේව් කළා. B කියන එකක් ඇතුලේ B ෆෝල්ඩර් එක ඇතුලේ drawing ෆයිල් එක සේව් කළා. මම පස්සේ copy කරලා ඒ කියන්නේ මම මොකක් හරි pen එකකට දාගත්තොත් AB ෆෝල්ඩර් දෙකම මම B කියන එක C කියලා rename කරොත් අර drawing file එක ආයෙ open කරද්දී අහනවා මේ කොහොර file එක කියලා. part file එක. ඊළඟ part එහෙමමයි part file එකේ ඔයා rename කරොත් at least අඩුම ගානේ part ඒ කියන්නේ file name එක rename කරොත් file එක නැහැ කියලා කියනවා. ඒ කියන්නේ එතකොට අහනවා නැහැ කියලා අහනවා අපිට මේ locate කරන්න කියලා. එතකොට ආයෙ locate කරාම හරියි. ඒ නිසා මේ හැම part මේ drawing file link වෙලා තියෙන්නේ part file. එතකොට එක part file එකකට drawing file එකකට වැඩි ප්‍රමාණයක් තියෙන්නත් පුළුවන්. අපි assembly environment එක ගත්තොත් part file ඔක්කොම ටික assembly එකට link වෙලා තියෙනවා. ඒකට මම assembly එකක් හදලා parts කීපයකින් එක part එකක් හරි අඩුවෙන් copy කරලා දුන්නොත් වෙන කාට හරි බලන්න කියලා. ඒකට assembly එක open කරාම අහනවා අනිත් part එක කෝ කියලා. හරි නේද? ප්‍රශ්න තියෙනවද?
So මේ මට ඕනේ මේ දැන් මේ page එකක් කරන් තියෙන්නේ. අන්න ඒක ගත්තේ ඉතින් පොඩ්ඩක් බලන්න.
right මේ layout එකද මේ කියන්නේ මේ
Layout එක.
drawings මේ page එක
ඔව් page එක.
right ඒකට file new ගිහිල්ලා මෙතනින් drawings කියලා එනවනේ මේකේ drawings click කරලා okay කරාට පස්සේ මෙතන dialog box එකකින් අහනවා මේකේ මට ඕන A4 ද මොකද්ද standard එක මේකේ තියෙනවා NC තියෙනවා ISO තියෙනවා මගේ ISO A2 select කරලා නැත්නම් මට පුළුවන් custom size එකක් දෙන්න මෙතන නැත්නම් මට පුළුවන් standard මෙතන තියෙනවා standard size එක select කරලා A2 okay කරාම මේක වෙන standard එක මේක තමයි නිකන් default වගේ එන්නේ title block එක ඒකේ තියෙන drawn checked approved manufacturing QA කොහොම ටික තියෙනවා මෙතන general notes finish මේ ඔක්කොම අපිට fill කරන්න පුළුවන් ආයි දැන් මේකේ අපි select කළා අපිට ආපහු වෙනස් කරන්න ඕන නම් මේ මෙතන sheet 1 කියලා තියෙනවා අපි වැරදි size එක නම් select කරේ උතන right click කරලා මෙතන තියෙනවා properties ඊයම ආයි මට මේක update කරන්න පුළුවන් එතනින් ආයි මම A2 ගත්තේ මට A2 වැඩි නම් මම මෙතන A3 select කරලා apply කරනවා ඒක update වෙනවා A3 වලට හරි නේද
සර් එතකොට ඒක හරි එතකොට මේ දැන් අපි ඉස්සලා 3D යන්දනේ සිලින්ඩර් එක
ඔව්
ඒකයි දැන් මේ අපි page එක layout එක හදුවාම දෙකම එකම තැන save කරලා තමයි දෙන්න ඕනේ නේ දෙනකොට
එහෙම නෑ හැබැයි පටන් ගන්න ඒ කියන්නේ මෙහෙමයි දැන් ලොකු assembly එකක් ලොකු machine එකක් හරි අඳිනවා නම් එහෙම කරනවා නම් ඔක්කොම drawings ටික ඔක්කොම parts assembly ඔක්කොම එක තැන තියාගන්න අමාරුයි අපි නිකන් project A කියලා folder එකක් අරගෙන ඒකේ මම නම් කරන්නේ එක එකනා එක එක විදිහට කරන්නේ මම කරන්නේ parts කියන්නේ folders තුනක් හදා ගන්නවා project A එක ඇතුලේ parts assemblies drawings කියලා එතකොට මේ project A එක ඇතුලේ parts ටික අර parts folder එකේ assemblies ටික ඒකේ drawings ටික අර folder එක ඇතුලේ ඒකට මම කාට හරි copy කරලා දෙනවා නම් අර project A කියන folder එක අරගෙන copy කරලා දෙනවා එතකොට යාට ඔක්කොම ටික තියෙනවනේ එහෙම නැත්නම් ওই part එකක් දෙකක් නම් අදින්නේ එකම folder එක තැන save කරාට කිසි ප්‍රශ්නයක් නැහැ ඒක ලේසි ගොඩක් කරනවා නම් අර විදිහට කරන්න හරිද any other questions okay so with that I will stop the lecture and next time I will teach you about the GD&T geometric dimension and tolerance okay, thank you